Good afternoon, everyone. Thanks so much for joining us today for our collaborative robotics webinar with Josh Watson. I'm Sean Kish. I'll be your host today. Before we get started with the webinar, I'd like to introduce our Deputy Director, Jeffrey Frum, and give him a couple of minutes to make an introduction. Jeff, thanks for joining us.
Hey, good afternoon, everybody. On behalf of Mark Anderson, the Director of Nevada Industry Excellence, and the entire NVI team, I want to welcome you to the latest in our series of Friday afternoon webinars designed to inform Nevada manufacturers about key topics of interest and need. The mission of Nevada Industry Excellence is to deliver comprehensive, proven solutions, fueling growth and advancing Nevada industry. So I believe that this webinar is very much in line with our mission as it talks about cobotics and certainly is talking about an Industry 4.0 topic that should interest all of us. So I hope you enjoy this session and look forward to seeing you soon. So back to you, Sean.
All right, thanks so much, Jeff. Before we get started, I just wanted to mention that we are recording this session today. Give you an opportunity to log out if you don't want to be recorded. I also wanted to mention that we will be making available Josh's PowerPoint presentation to our attendees today. We'll also be, as I mentioned, we're recording this, and the recording will be posted on our website as well. And I also wanted to mention that Linda Schoen will be assisting us. She's our teammate in Reno area. And Linda's going to be monitoring our chat room today. We encourage anyone that has questions come up during the presentation to type those into the chat room. We'll hold off any questions until the end of the presentation. Then we'll go through some commonly asked questions, and then we'll ask Linda to read the questions that come through in the chat room. So thanks for your help today, Linda. First, I'd like to introduce Josh Watson. Josh is the founder of EIS Automation, a Las Vegas-based automation and system integration firm. EIS specializes in collaborative robotics, machine vision, ID traceability, and packaging solutions. Before starting his business, Josh worked in several large-scale print manufacturing firms with a focus on process controls and automation. This included machine vision for defect detection and robotic palletizing systems. Josh was also responsible for integrating new equipment into the production line. Prior to that, Josh completed a 3-year apprenticeship program for print technology in Langen, Germany, and graduated in 1998. Josh then completed his mandatory military service in the German Army in 2000. Following his service, Josh remained in the German Army Reserve and attended the Gutenberg Technical College in Frankfurt, graduating as a certified engineer in 2005. Josh, thanks so much for joining us today. We're really excited for your presentation on collaborative robotics.
Yeah, thank you so much, Sean, and thanks everyone for taking the time on a Friday after lunch to join a webinar. Sean mentioned it, I'm a quintessential Cold War child, German mother and American GI. So you might hear a little bit of my accent coming through. I'm bilingual and also a dual citizen. So the first 28 years of my life I spent on the other side of the pond, so to speak. So again, thanks for joining. I hope that I can share maybe a few things about collaborative robotics today that are helpful to you. I know it's a big buzzword right now, so hopefully a couple of things will help you understand the technology better and how it could apply to your manufacturing environment. So the topic today, as you know, is collaborative robots. You see by the two logos that are underneath that today's discussion will be about the TM Omron series of collaborative robots. There are many other platforms out there. We have chosen this particular platform to specialize in for a number of reasons, and I'll explain them to you as we go on. We are factory certified on the platform, and since January 2019, so just about 1.5 years or a little over. Yeah, so just a quick introduction, EIS Automation. I started the business in late 2012. I don't count that year. So 2013 was the first year in business. If you want to call it that, it was on my knees in the garage. So it was before we had an actual suite and operated. So that went on for a few years. But here we are, 2020. We're still around. We're growing. And also over the years, we kind of simmered down what we want to be good at and what we think or where we can bring value to the table. Of course, one of the topics is the collaborative robotics platform. Once you have the ability to implement robots, it can be used in so many different industries and different applications. So we thought that's a good technology to grow into and become good at. Prior to that, we already developed our own product line, the Tarsius series, that's both machine vision and ID and traceability. You see here on the bottom left, we have a barcode reader and here a machine vision system with cameras. So what we've done is we've developed our own product line that includes the bracket kits, control panels, and also the software development. So we provide basically an entire solution for these products. Third item is packaging. Over the years, we've gone deeper and deeper into the packaging world, and that includes what you see here is a flow wrap machine, also very deep into shrink wrapping. And you can already tell that all these three topics here, they start to make sense because they all can be integrated together to create entire solutions, even though they are available individually if needed. And then last but not least, in the packaging world, everybody who has a printer knows what he needs at some point in time, and that is ink cartridge. So in this case, we also offer the film for packaging machinery, specifically flow wrap or BOPP film and shrink wrap film, a large selection. Yeah, this is our focus. And a few things that you don't see here is, of course, we take care of motion control and also software development, whether it's in the industrial world or it is the Windows world. So we do quite a bit of .NET development as well. It's actually one of the items we carved out for ourselves as a niche, is the merging of the industrial world with the Windows world. So yeah, the TM Omron series of cobots has a total of 4 models. I'm going to go over each one of them. The smallest guy in that series is that's called the TM5700. And I apologize in advance. All these specs are metric. That's how they are presented from the manufacturer. But so the TM5700 is the smallest of the group. It has a payload of 6 kilograms, so roughly about 12 pounds, and a reach of 700 millimeters. So the product name in this case, the 700, means 700 millimeter reach, and it has a max speed of 1.1 meters per second. The second model is the TM5900. You can see here, interestingly enough, the payload actually goes down from 6 kilogram to 4 kilogram, but the reach increases to 900 millimeters from 700 millimeters. 3 feet are just about a meter. So just to kind of give you an idea what that means, it's roughly approximately a meter reach. And the max speed went up from 1.1 to 1.4 meters a second. Again, to kind of give you an idea, a normal walking speed for a human is about 1.7 meters per second. So slightly slower than a human walking, maybe. The third model is called the TM12, and interestingly enough, the manufacturer now changed its naming convention from reach to payload. I don't know why that is, but it has a 12 kilogram payload, or roughly 24 to 25 pounds. It has a reach of 1,300 millimeters, so about 4 feet, and it has a max speed of 1.3 meters per second. And last but not least, out of the group, we have the TM14. Again, the payload is higher by 2 kilogram, or slightly above 4 pounds. And the reach is reduced and the speed is reduced. So you can already tell the more reach a robot has, typically the payload goes down a little bit and the speed goes down a little bit to be able to manage and handle that payload at the end of the arm. So these are the 4 models available. We have the TM5900 here at our shop for testing and demos. So if you're ever interested in seeing one live, you can definitely stop by at our shop here in Las Vegas, and we can demo the robot to you firsthand if you'd like. So of course, it's always a question, what are good applications for a robot like this? And there's a large amount of applications. I put a few in here so to kind of maybe trigger some thought and give you some ideas. Definitely one application is screwing. These robots are available, or I should say there are tools available that you can attach to the robot. They're standardized for screw feeding. So if you are assembling a housing that needs 4 screws, and currently there's an employee putting the screws in by hand, that robot could take the screw and automatically screw the screw in with a given torque for that particular product. One thing that gets more and more popular, we haven't done one of these yet, but it definitely is becoming more popular, is either gluing or dispensing application. It could be either glue or it could be grease or anything that needs to be dispensed in a very precise path on a product and also in a precise amount. The robot, of course, can follow these paths precisely and dispense a very precise amount of whatever needs to be dispensed. One big aspect right now is machine tending. This typically refers to CNC machine tending. Anybody who has a CNC machine or a number of CNC machines, the robot can actually put the product in, take it out, close the door if it's not automatic, start the cycle and repeat. So it can pick, for example, many raw products from a cart, put them into the CNC machine. Once the cycle has finished, it'll take the completed part out, put it on a second table, and take another part until all parts are finished. It's a very popular application for CNC or manufacturers who have CNC machines in their factories. One thing that is frequently used, and we are actually setting it up at our shop right now, is called conveyor tracking. This is mostly for applications where a product is transferred from one location to another while it is in motion. So to make an example, if you are a bakery or a food production environment, you have a product coming down a conveyor, the robot could actually detect that product and pick it up in motion and then place it, for example, in a packaging machine like a flow wrap. So you would essentially eliminate touch points. And also now with COVID, more and more becoming a big topic is you eliminate the potential for cross-contamination if the robot completes these tasks. Then, of course, one that applies to just about any industry is pick and place. Pick and place could mean anything. It's not limited to a specific product. It really just means that you're picking a product up from one position and placing it into another position. And when you compare it to conveyor tracking, typically pick and place means it's stationary and not in motion. So you can pick just about anything you'd like as long as you're within the payload and the reach of that particular model that was chosen. That could be vacuum, that could be a gripper, and we'll talk about that a little bit here in a second. Of course, you can do assembly. Assembly is a very good application for a robot simply because it's very repeatable. And of course, over time, it doesn't lose focus. The eyes don't get tired. It repeatedly, the first assembly has the same quality then 8 hours later, maybe the 5,000th piece of assembly. And the repeatability of the robot, of course, plays into this. So you can pick up very small parts or multiple parts and assemble them in a very repeatable fashion. The robot itself, you might have seen it at the beginning. I'm going to try to show it here. You have the robot flange, and then you have a small attachment here. That attachment is actually a color camera that is part of the robot as a standard option. It's a 5 megapixel color camera, and with that camera, you can do QC inspection. You could count pieces, for example. You can read any 1D or 2D barcode. You can do simple quality control with that camera. And so it's a very good option for simple inspection applications. And then last but not least, of course, it could be used for palletizing. There's actually a complete solution out there that can palletize 2 pallets right next to one another. It comes with an entire software kit that literally allows you to start palletizing automatically, probably within 15 minutes of after it's installed. So it's a very convenient package, and you can do 2 pallets at a time. On the top right, you see here all these little arms and tools coming out of the brain. It really just means that the opportunities are endless. So if you have an idea, anything that you see that you would like to automate that is not part of these pictograms, there's a good chance that it nonetheless can be completed. It's not limited to these few applications that I just described. Now I'm going to share a little video with you. This is a video from February this year when we were at the PAC, the CBD show here in Las Vegas. And what we did is we created a full automatic packaging solution. So you can see how the robot is integrated and would work in a full line that includes packaging, label application, and data collection. So I'm going to share my screen real quick to this video, and I'm going to start and stop the video a little bit to point some individual items out while you watch it. Josh with EIS Automation in Las Vegas. Today I'll be presenting to you our end-of-line solution that we have developed with our partner Preferred Packaging. What you see here is 2 monitors. So what you see here is 2 monitors. One is a vision system that we have integrated for quality control that is outside the robot. And here's the robot monitor. What the robot does in this particular application, it counts the jars that need to be picked, and you'll see that in a second. One for the machine vision system and one for the robot vision system. Here we have a takeover point, at which point the cap is already applied and the product is filled. We have an ingoing quality control to check, for example, misplaced lids that are automatically rejected, so the robot doesn't receive a product that is not properly oriented or that is not applied. Once the robot sees. So what you see here is we made a little linear actuator to collect 8 of these jars, and once there's 8 of them, the robot automatically picks them. It'll automatically pick the jars, place them into the tray. Once placed, it'll automatically advance the pack into the preferred pack box motion shrink wrap machine. The shrink wrap machine will automatically cut off the last pack, transfer to the tunnel, at which point the film is shrunk down. Once the pack exits the heat tunnel, it transfers to a label applicator conveyor, where a label is automatically applied to the pack, and through a barcode system, we're reading the barcode and documenting a record of the production. The result is a fully packaged, labeled, and documented product for the packaging industry. Again, I just wanted to show a video of the entire solution. This includes the machine vision, the barcode. So it doesn't have to be a complete solution. It could be the robot itself or the machine vision itself, but it's nice to see things working together as a fully integrated solution. So what are some of the benefits of cobots in an operation, right? So they're definitely very easy to program via TM flow. So instead of writing physical code or needing an engineer to do it, TM flow allows you to use function blocks rather than actual code. And it also allows you to guide the robot to a position that you'd like and just push a button and say pick, and then you point them to the next location and say place, and you have created a program without even going to the screen. Another benefit, of course, is repeatability. For the TM5 models, that's plus minus 0.05 millimeters. Again, to kind of make an analogy, the average human hair is about 0.05 millimeters. That's the repeatability of this robot. And the repeatability is chosen as a term in place of accuracy because it's the robot's ability to repeatedly reach a position in the robot envelope And that holds true for thousands and tens of thousands of cycles. So as you can imagine, whether you pick something or you assemble something, you have a very high level of quality because the repeatability is so tight. For the larger robots, the TM12 and the 14, that number increases to 0.1 millimeters, so about twice the thickness of a human hair or average human hair, and still very precise. One item that is more of a side effect, it's not a side effect, but of course, when you have repeatable jobs, an operator doing something over and over and over again, the robot has of course, the potential to solve and improve workplace ergonomics. And the side effect is, or could be, reduced cost for workers' comp. The robot doesn't get carpal tunnel from repetitive motion. It also doesn't typically get injuries from awkward positions or lifting from awkward positions. So all these types of things are areas where a robot like this could improve the environment for the workers and the employees by taking over some of these tasks. That of course flows right into the consistency of the quality in the operation. So once you have the repeatability or you have replaced some of these tasks, you will get a consistent output. And that holds true for thousands of hours of operation. And not only that, it is the same quality, whether it's first shift or second shift or third shift. Just like, unlike an operator that might get tired or may pay less attention after so many hours of doing it, that of course is not a factor with a robot. Of course, a big part, and that's what's called a collaborative robot. It can collaborate with humans in the workspace. So it makes for a safe operation with humans collaborating together without any guarding or shielding around it. Cobots are the only robots approved for operation without guarding around the envelope. Of course, again, I mentioned it earlier, the reduced touch points help in many applications now, whether that's medical or it's food production. It eliminates potential cross-contamination by reducing touch points or eliminating them altogether. And last but not least, I think that's oftentimes a topic that the robot eliminates work or employees. And from our experience, that's not the case. If at all, it frees up certain employees, so now they can do meaningful tasks. So we have not installed a single robot yet that resulted in an employee getting laid off. As a matter of fact, these employees then were promoted to robot operators and felt much better after it was installed. And now we're doing meaningful tasks instead of repetitive type tasks. So it's maybe I try to take a little bit of the fear of the technology away that it costs jobs, but I don't think from my experience or from our experience, that's not the case. So a little bit, I didn't want to make it too technical, but I kind of want to throw in at least some information about some technology and why we decided to go with the TM Omron. And the reason is that Omron, being one of the largest control components manufacturers in the world, I'm not aware of any other company that has that many components under one umbrella. And what that means for a robot solution like this is that it is deeply, deeply integrated into the controls platform of Omron. And that not only holds true for any controllers, PLCs or packs, that holds true for the communication that it comes along with it. In this case, you see your EtherCAT, for example. It can include servo drives, VFDs, and of course, all safety equipment for seamless integration. It does not mean that it's limited to Omron. We could integrate it into any other platform as well. But there is a benefit, of course, when everything, the hardware comes out of one hand, it makes for a very seamless integration into an entire system. So again, not limited to this, but it's certainly a big benefit. And that includes also IO-Link, any sensors. One thing that you don't see here is is the integration into the Windows world. For example, right now we're working on a project for a medical company, a medical device manufacturer, and we are actually integrating the robot into their Windows-based production control system. So we are developing a custom interface that helps the robot solution communicate with the existing production system. So one big part is, and you probably have heard the term before, is end effectors, sometimes called end of arm tooling. And end effectors are really the attachment that goes onto the robot. The robot delivered with just a flange with 4 bolt holes, as you can see it here. And the robot can be equipped with a number of different end of arm tools. Here you have a 2-finger gripper from Robotique. It could be a compression gripper. I think this is a Schunk, and then a similar model from Toyo. All these manufacturers typically develop products that are integratable easily with all the robot platforms out there, and that holds true for all of these. Also on the right here, you see a modular vacuum system from Schmalz. And on the bottom, you see 2 pictures from end effectors that we have developed custom for applications. So we designed, for example, this blue attachment that you see with the pneumatic tubing, and then we had we mounted 8 PIAP suction cups. Those are the suction cups that you saw in the video earlier to pick those CBD gummy jars. And on the right hand here, you see I am clicking through. I try to make space, and each time I click, what you see here is a project we just finished, I think about 3 weeks ago. And this particular application, there was very little space for the end effect to go in because we had to insert a sheet into a machine. And there was only about a 5-inch gap. So we designed a tool that allowed us to pick the entire sheet up. As you see it here, we have 1, 2, 3, 4, 5, 6 small suction cups. And the end effector is the size of the sheet. So we're picking a sheet out of a tray and kept the end effect very shallow to move this sheet inside a piece of equipment. So we typically tailor everything we do towards a customer's specific need or application. It doesn't have to be one of these off-the-shelf solutions as I showed up here. Now we have another short video. This is not an official marketing video. This is just something so you can see the robot picking parts and with the help of the vision system. So I'm going to start this from the beginning. So what you see here, we just put a few small IC chips, integrated circuits, on a conveyor in a random orientation. So they're not lined up in any way. We just put them there. And as you can see, it's a random orientation. So we are presenting those components now to the robot. And for a brief moment, you see the robot turning on its vision light. So now it's taken a picture of all these chips. So here you see what the robot detected. The robot detected every single chip, and you see it has 2 arrows per integrated circuit. So it has detected the angle of each and every product on that conveyor. And what it does now, it automatically compensates for that random orientation and stacks them out in a linear fashion in 2 rows. And that's it. Yeah, so we stacked them out. The suction cup we used for this application was slightly too large, so there's a little bit of a variance, but it shows the capabilities. So this could be done in a very precise fashion if we would have had the right suction cup, so it picks up better. But just to show the application, I'm going to switch to the other screen again. So of course, when the robot works in close proximity to humans, you might ask yourself, how safe is this, right? And these collaborative robots come with a number of features that make them safe to work in an environment with humans. And without getting deep into safety, and the robot platform complies with ISO 10218 and ISO TS 15066. Again, we could probably fill 10 webinars just with these two ISO compliance, safety compliance features. But what matters is that the robot platform complies with all safety features that are needed, and which means there's nothing that needs to be added except maybe some safety scanners or things, but they're already meant to be integrated, and the robot itself has all the safety features inside the controller to make it to comply with these two ISO programs here. The robot, of course, has programmable speed and force limits. That's what makes it safe. So when a robot is programmed, there's settings not only for speed and force, but also for certain areas. You can specify a safety area for a shoulder, for example, or when it's moving close to the head, you can specify that. And actually in the robot setup, there's a little human, and you just click on the areas that you're exposed to, and the robot will automatically make that a safe environment. Then what you see is more from a design perspective. I think we all have seen at trade shows or videos on YouTube, large industrial robots, and there's a couple of design differences. Typically, large industrial robots or fast-moving robots have motors protruding. And as you can see here, collaborative robots don't have any protruding motors. Everything is inside the joint. This is a 6-axis robot with each of these joints or axes having a motor inside the joint, including the wrist, and non-exposed. Then, of course, as you can see, they're designed with large areas. So there's nothing that is a small area that could potentially, when you have contact with it, injure a human or damage a piece of equipment. And then, as you can see, everything is designed in a rounded fashion. So motors, caps, covers, everything that you see doesn't have any sharp corners. Everything is rounded. So if there's a potential human walking into the path or anything, or the operator just enters the path of the robot, there's no sharp objects or anything that could injure a human potentially or damage a piece of equipment. And of course, there's another aspect of safety, and that's the application itself and the integration planning. There's, of course, the end effector. We already just talked about it in the slide before. There's different end effectors from a suction cup or vacuum cups, grippers. And of course, there's dangerous applications. So maybe you have a cutting application and there's a blade at the end, or maybe you're soldering something and you have a hot end. So these are things that need to be thought of when integrating a robot like this, because of course that then plays a role in the safety of the application. When designing a system, of course, there could be a number of safety devices around the robot to add to the robot's safety itself. We frequently install area laser scanners, and typically the way they are set up is that you have 2 zones, and you're scanning an area, and if an operator, for example, enters zone number 1, the robot will slow down to what's called collaborative speed. And then if an operator enters zone number 2, which is very close, for example, to the robot would automatically come to a stop and then resume operation after the operator has exited that zone. It could also be depending on application, a light curtain, or it could be a foot, a pad an operator could stand on. So there's a number of things that can be done to make it safe. It's not always the same. I will say if the system only operates in collaborative speed, then no additional safety equipment is required. And then a very important item that is oftentimes, I feel, neglected is the risk assessment. So typically it's recommended to have a risk assessment for every robot that is installed for a particular application. We offer that as an add-on service if a customer would like us to do it for them, but it's certainly something that can be done in-house if there's a safety team or the knowledge is in-house to do it. And really what a risk assessment is at its core is taking the application that the robot is working in, and in a logical fashion, step by step, think of every potential outcome that could happen and what the risk is and how to alleviate that risk. And so if OSHA ever comes over for a unannounced visit, then you can go to the shelf and pull off a folder and say, we've thought this through. These are the risks we have identified. These are the measures we have taken to minimize that risk. And it's really just to show that one has thought the application through in detail. Yeah, and that's it. I know it's nice and crisp and short. I hope there was some good information part of this. Again, I try not to make it too technical. If anything comes to mind that, or thoughts that I triggered or you thought about after this, please feel free to shoot me an email with any questions. And I think with that, it's back to Sean, and I think he is gonna do the question. Thank you so much for listening. And again, I hope it was helpful and of benefit to you.
Well, thanks so much, Josh. I really appreciate that. You mentioned your role as a systems integrator several times, but just go into a little bit more detail between just a straight distributor who just has a set of products to sell versus a distributor and integrator who can customize an application for a client. So just describe your role, what that means, what a systems integrator does.
Yeah, system integrator, oftentimes you might even see it described as just an SI, is typically a company that has a solution approach. So unlike a distributor that takes on certain, or has a line card and takes on certain products and provides just the product, a system integrator is a company that designs solutions, right? That doesn't mean we can't provide just components. As a matter of fact, the robot, for example, of course, you could just buy the robot. If you already have 3 of them and you feel comfortable with the platform, there's not a problem to just provide the robot. But a system integrator typically goes a few steps deeper, and that's really the main differentiating factor from a distributor, is that we provide full solutions, and that includes design, electrical engineering, software development, and oftentimes custom development for specific applications or industries to provide a turnkey solution. Sometimes there's a need for what's called an assisted integration, and that's mostly for customers who already have maybe an in-house department or in-house capability, and then it becomes an a la carte thing. Hey, we would just like the robot and the end effector, or could you do the electrical engineering and the risk assessment and just the robot? And this way you can pick and choose. But the main difference to a distributor is that we typically provide value add and assisted integration or full integration into environments that include every aspect of a system.
Super, thanks so much, Josh. I've been out to your shop, and I know that you have got some new technology that are helping you to build customized solutions. So do you want to talk a little bit about maybe the 3D printing that you're able to do now?
Oh yeah, so yeah, 3D printing. I think we've gotten into it maybe 3 years ago, and just bought back then what was considered a professional model, and wanted to try it out. And I think the person that was given the responsibility was ready to throw it into the dumpster after 5-6 months. But since we've spent quite a few hours and quite a few different materials and tested and tested and then tested again, and now I can say that we really do a lot of 3D printing for some of the custom applications we have. And really what it does is it helps for design. First of all, you can design and test something really quick. If you later on want a CNC machine, at least it gives you something quickly to test with, or even as a full production piece. And yeah, it's quicker. The materials have gotten stronger. They've gotten UV resistant. They've gotten flexible. We have developed an entire mounting bracket kit that we print with carbon fiber infused nylon. And we have asked one of our customers up in North Las Vegas to be a beta tester, AKA guinea pig. and they've been using these now, I think, for 2 years without a single one failing, after repetitive tightening down, loosening, readjusting. So it really is, it's not good for everything, right? But I think it falls into the category of additive manufacturing, and you can do great things with it. We use it for a lot of things if it's a good fit. And if it's not a good fit, then we would also go the traditional route, like go into a machine shop or something. But it certainly has created a lot of flexibility. It can lower costs in many instances, and it also makes it a much shorter undertaking. Mm-hmm. From design to first piece, you typically just wait a night of printing instead of 2 weeks for a CNC shop to manufacture something for you. So.
Super, thanks so much. Then service and support. Talk a little bit about your role. You know, is there any regular maintenance required, or if something does break, would you actually come in and pick up the equipment or replace it with a new?
So typically, maybe in general, what I should say is that we provide systems for OEMs. So we have customers all the way from New York State down to Florida. Our OEM customer in Florida also exports equipment into the world. So I think as of right now, we have servo systems, motion control systems that we have built here in Las Vegas that are installed in Shenzhen in China, in Canada, multiple systems, in England, in Holland. So typically what we try to do is design systems keeping in mind that they might be installed anywhere. And when I say this, we typically try to make them remote serviceable. So even if it's not local, we can still remote log in and at least do a remote troubleshooting session if there's a problem. I will say that we had a servo failure, for example, in Shenzhen, where the customer hooked up our system not to the low side, but to the high side of the transformer, and the smoke came up quickly. And what the benefit is of a system integrator is that we work really, really close with these manufacturers, whether it's Omron, Parker Hannifin, IDEC. There's a very close relationship. So we were able to help that customer that day when the customer connected the system wrong, the controller was fried. We had a new controller on site in Shenzhen within 24 hours because Parker Hannifin had stock in Beijing. And the Parker Hannifin engineer went there, installed it, and downloaded our program, make the machine running, help the machine get running again without us ever having to jump on an airplane. And that really shows how close collaboration with manufacturers can be of great benefit to any customer. Of course, locally it's easier. You can jump in the car and be anywhere in the valley in 25 minutes. So it's a benefit to be local for sure, right?
Super. And then let's talk about some of the manufacturing industries, because we have such a wide variety of manufacturers. We have candy manufacturers. We've got manufacturers making pens, manufacturers making gift cards. And so sometimes I think a manufacturer might think, well, you know, we're making candy. Can you really help us? Or we're making gift cards. How in the world can automation help us? So just talk about the fact that these automation is being integrated into, you know, a wide range of industries now.
Yeah, that's correct. So we really started, the first few customers ended up being through, I don't even know how it all evolved, but it ended up being that the first customers were in the credit card and gift card industry. And we quickly developed barcode systems and machine vision systems that could be used in secure environments, whether that's Visa facilities that manufacture Visa cards, as you can imagine. Data tracking traceability is really, really a focus. Nobody wants his credit card, manufactured twice, right? So, and then from there on out, it grew into other environments. So today, we have customers, medical device manufacturers as customers. We have food production. One of our customers manufactures all the trail mix for Trader Joe's. We install vision systems for them for defect detection. Yeah, it really goes across the board. We have a gaming company here in town that is a customer of ours. It really, it's not so much limited to specific industries, but more application dependent, because pick and place could be something you do in any industry.
Right.
You do packaging in any industry.
Right.
And so the solutions that we provide are not limited to a specific industry. But what we do is we sit down with customers to learn, if it's a new industry, to really learn as much as we can and see what their focus is, what they emphasize, so we can together create a solution. And if I can add one thing, this is actually one of the items that we frequently do is we go into a facility or a customer and we help identify what would be a good fit for automation.
Right.
Maybe there's 5 ideas, but maybe out of these 5 ideas, maybe 1 or 2 would be a good fit. And then we help say, hey, this could be accomplished. These 2 really good, these 3 maybe not so much. And yeah, that's one of the things we definitely offer.
Yeah, thanks. I think that's really important for our clients to understand, is that you can actually help them identify those, top opportunities for them to integrate automation into their system. Let's open it up to our attendees. Linda, do we have any questions from the attendees today?
Yes, actually, we have 2 questions and a comment. I guess I'll do the comment first. Nathan from George T. Hall is a system integrator and wanted to know if you wanted him to weigh in, but he said that you did a great job answering the question.
Okay, very good. Yeah.
One question is, upskilling and reskilling the workforce is a critical piece in preparing manufacturing employees for the near future. Can you share more about specific skills using cobots that will help develop?
Well, I think the nice thing is that the more these types of platforms come out now, that you really don't need to have any specific knowledge prior to implementing it. I'm going to say that anyone in this webinar now, if I were to bring the robot or you were to come to our shop without any prior knowledge, we could probably, or you could probably within 20 minutes create some moves with the robot. And I always make this example with, if you can use a phone, there's a good chance that you can use the robot successfully. It can be trained quickly. I'm not saying that you can do the most complex applications in a week or 2, but you can certainly within an hour or 2 get a good feel for what the robot can do without having any prior knowledge. And of course, we would train in specific things if there are questions. But that's the nice thing about these platforms, that you don't need to be an engineer. You didn't have to go to school for many years. As a matter of fact, they're oftentimes used in environments where the operators get trained and then the operators are using it. I mean, the last customer that we installed this robot is operated now by a young lady who is an immigrant and has never even completed high school. I mean, just to kind of give you an idea that it really, it's very, very user-friendly. I hope that answers the question. I'm not sure if that was what was, but we do, I mean, kind of, yes, training is a big aspect. And I will say that as a system integrator, we do train, right? So whether that's PLC programming, all IEC 611 languages, if that's of interest, that we do quite a bit, get a little bit more technical, maybe any communication protocol. We do EtherCAT, Ethernet IP. We can do, of course, ladder logic. It's not as dominant anymore as it is, but function blocks, PLC open motion, anything that is a 21st century automation technology. Typically we early, and we also train on that if it's needed by customers who have in-house departments that take care of that.
Thanks, Josh. Linda, were there any more questions?
Yes, this question refers to the last video, and it was a question about how fast the cobot did that motion.
Oh, well, I wasn't exactly sure what the speed setting was, but it is a TM5900. So on the upper end, it was 1.4 meters per second, but I think it was not max speed. I think, if I recall right, this was maybe 65 to 75% of max speed. So maybe a meter per second, something around, I don't know. If I were to guess, I would say probably about a meter per second. Yeah.
And that translates into how many feet?
Okay. Roughly about three feet.
Thank you.
Per second. Yeah.
Thank you. Linda, any more questions?
No, no more questions.
It's actually, that's a very good topic. I want to comment on this because we go to trade shows, not so much anymore, but we used to go to trade shows. You watch videos and you see these robots flying around really fast. And these are typically industrial robots behind a work cell. They're inside a work cell with guarding around it. And collaborative robotics, the sheer nature, they're not high-speed robots. They're repeatable, and they can be integrated within a workspace of humans, but they are not high speed. That's definitely one of them, yeah.
Josh, can you go to the last slide for me, please, with our contact information? And
yeah, of course.
Thanks. Josh, thanks again. I really appreciate it. We're so lucky we've got your expertise here in Nevada, and we really look forward to introduce you to some of our clients. I know we had a nice group on the webinar today. This is the team South and North that can help introduce and set up some initial meetings, virtual meetings with Josh. So again, here's your team, the project managers all listed here. You can contact your project managers and we'll be happy to set up a initial Zoom meeting with Josh to discuss some of the potential opportunities if you're just getting started with automation at your facility, right, Josh?
Yes, perfect. Yeah, again, thanks, Sean, and your whole team for the opportunity. So I hope it was helpful. And again, yeah, reach out to any of NVIE or my email address, and we can talk a little bit deeper about even other things. It doesn't have to be cobots, right? So.
Super. Thanks again, Josh. Really appreciate it. And then in closing, I wanted to mention that our next webinar in 2 weeks will be on export tech. I'm really excited. We've offered the export tech program through NVIE for many, many years, and now it's been updated and virtual. It's being offered virtually, and it's also an allowable expense through the GOED Governor's Office STEP grant. So clients can sign up for the export tech, sign up for the STEP grant, and they'll be able to take this new updated export tech. And this applies to anyone who's already taken it. Many of our clients go through it several times because there's always opportunities to go in new countries. And so again, we're really excited to be offering the webinar on the updated export tech program 2 weeks from today. And Linda will be sending out a flyer with information about that so that you can register. A couple months ago, we actually had people from the governor's office, Deanna and her boss, actually spoke to us about that STEP grant. Josh, you actually applied and received a STEP grant, I believe, last month.
Yes, we did, yes.
$5,000, I believe, correct?
Mm-hmm.
Yeah, so I helped you through that process. It wasn't too bad, was it, filling out that grant application?
Yeah, I mean, it was okay. I mean, anything with the government is has its in and outs, but yes, we ended up, I mean, if you focus on it, it takes 15, 20 minutes. That's what it is.
Right. So again, I wanted to mention that again, if anyone's interested in expert tech, once you hear about it in a couple of weeks, you can reach out to any of your project managers. The STEP grant is now opened up again. And so even if you want to get started talking to your project manager about the STEP grant, it's up to $10,000 maximum. Josh applied for $10,000. He received a $5,000 grant. And again, that was him and I spending about 15 minutes filling out a 12 or 13 page grant application. It's not too bad for $5,000, right, Josh? Spending 10 or 15 minutes. Pretty
No,
good.
that's good. I mean, it's also very flexible in what you can use it for.
Yes.
So
A lot of options now.
a lot of options, yeah.
Super.
So, no, it's good.
Super. Thanks again, Josh. Thanks everyone for joining us. And again, keep an eye out for the upcoming webinar in 2 weeks regarding our expert tech training. Thanks everyone and have a nice weekend.
Okay, thank you. Have a good weekend. Bye-bye.
Thank you.
Bye, Josh.